In this video, I'll show you how to calculate the arc length of the curve. So really all you need to know is this formula. Boom, video's over. I'm messing with you. Now, this formula is basically just the formula. You can follow all the formats and everything. dy over dx, if you don't know what that means, is simply a first order partial derivative, and it's equivalent to just saying f prime. Alright. And when you square, that doesn't mean you have a second order partial derivative. You're just squaring the function of your first order. And if you want a visualization of what this actually solves for, let's say you had some function, some really weird curve that looks like this. There is absolutely no geometric way that you can solve for the length of this function, right? For you to say maybe this is 1 centimeter and this is also 1 centimeter, and you did that throughout the entire thing, well, that wouldn't make sense because you're calculating the centimeters in straight lines. So how do you actually calculate the length of this curve? Well, you can use this arc length formula. And if you want to calculate it from A to B, if you want to calculate the length of this line from A to B, then A would be the lower bound for this integral, and B would be the upper bound. So in an example, if this was x equals 1, and this was x equals 10, then your lower bound in the arc length of the curve would be 1, and the upper bound would be 10. Now, the thing about solving arc length of the curve problems is that a lot of the functions you're going to see are very easily integratable. They're very annoying. You're going to have to use trigonometric substitution. You're going to have to use u-sub. You're going to have to use trigonometric manipulation. There's just so many annoying things. So hopefully your professor doesn't make you solve anything of those likes. Hopefully they just make you set it up, because that's the fun part. Just setting it up is the easiest free points that you can get on an exam. But you might also see that the integral is set up like so. A and B, square root of 1 plus dx over dy squared. dy. Now this integral is in terms of y now. Well, why do I say this? Why is it dx over dy now? This simply means that your function is in terms of y. So y is the dependent variable. Before, y, maybe some example function would be y is equal to x squared. Now, your function would be x is equal to y squared. So, in this case, if you have some function where x is isolated and y is whatever your function is in terms of, then you have to use this formula here. But really, all in all, they're interchangeable. The logic is all still the same. But instead, your function bounds are just slightly different. If you wanted to calculate the arc length of the curve from, let's say, y equals 1 and y equals 2, actually, this is not a real function for y. Let's actually do it like this. If you wanted to calculate the arc length of the curve from y equals 1 to, let's say, y equals, sorry, this is a y equals 0 here. Y equals 0 and y equals 2, then your bounds for your function would be 0 and 2. So, really, the logic's still the same. dx just means this function's in terms of x, so you use the bounds of x to calculate your arc length. And if you have dy, right, that means your function's in terms of y, so you use the y bounds to calculate the arc length of the curve. So let's move on to some problems. So let's go ahead and calculate the arc length of the curve for this function here, from x equals 0 to x equals 2. Okay, so first thing you want to do, you want to set up the formula. So the length is equal to, we know our bounds, x equals 0 and x equals 2, so the bounds of the integral are 0 and 2. And the formula is set up with 1 plus the first order derivative squared. So the first order derivative in this case is, well, x to the power of 1/2, using some power rule. So this is the square root of x squared dx. If we want to simplify this integral a little bit, we can eliminate this square root. So all we get is 1 plus x dx. Well, this is really just a simple u-sub problem. So if we set u as 1 plus x, du is equal to dx. Therefore, we can just simply write down the integral like so. 0, 2, replace 1 plus x with u, and replace dx with du. That actually looks like a 4. Let's write down u instead. du. And the antiderivative of, sorry, the bounds are wrong. Actually, it's not 0 and 2. The antiderivative of square root of u is 2 over 3u to the power of 3 over 2. Alright, now all we need to do is substitute back in for u, so we get the function 2 over 3 times 1 plus x times 3 over 2. And our bounds of this integral are 0 and 2. So if we plug in 2 and 0 into this, we get 3. So 2 over 3 times 3. And then if you plug in 0 into here, you get minus 2 over 3 times 1 to the power of 3 over 2. And this is your answer, which is the arc length of the curve. So we have a linear line here. You could honestly just calculate the arc length of this using hypotenuse, but you could use that as another method to double check it. So let's go ahead and set up the integral. The integral is from 0 to 1, as our bounds for x are from 0 to 1. And our arc length of curve is set up by the square root of 1 plus the derivative of our function. Well, the derivative of this function is simply 3. So we have 3 squared here, dx. And if we set up this integral further, we get square root of 10 dx, which is equal to the square root of 10x from 0 to 1. So if I were to plug in 1 here and plug in 0, you would just simply get the square root of 10. Therefore, the square root of 10 is the arc length of this function from 1 to 0. 0 to 1. Alright, let's go ahead and solve the arc length of the curve for this problem. Well, this time we have a function in terms of y. Well, if you have a function in terms of y, it's going to be equal to some value x, right? X is now your dependent variable in this case, but it doesn't really matter. The math is all still the same. You can honestly just replace y with x and you can solve it in terms of x, but your teacher might not like that very much, depending on their preferences. But 0 to 1 is the bounds for our integral, and the square root of 1 plus f prime, in this case, is 3 times y to the power of 1/2, which is just equal to 3 times the square root of y. Alright, so if we put 3 times the square root of y here and square it, I put it with respect to y, you can already tell that this formula is basically the same as what you've been using. So hopefully your teacher doesn't give you any complicated arc length of curve problems on your exams. It really isn't what they should be testing you on. They should be testing you on if you know how to set up this integral, not really know how to solve this integral, because all of that is either trig sub or trigonometric manipulation or maybe u sub, but like that's not the point of what you learn. You're trying to learn how to calculate the arc length of the curve. A calculator can solve this integral for you. So hopefully your teacher doesn't do any of that from 0 to 1. And if we simplify this integral, we get 9y here, dy. So let's use a little bit of u sub to solve for the rest of this. du is equal to 9 dy, therefore du over 9 is equal to dy. So if we set this integral in terms of u, we have the square root of u times du over 9. And if we wanted to solve for the new bounds in terms of u, we would just plug in simply 0 into here. So if we plug in 0 into your function of u, then you get 1 plus 9 times 0, which is just 1. If you plug in a 1 into here, you get 1 plus 9 times 1, which is 1 plus 9, that's 10. So this is your new integral in terms of u, using with new bounds. So if I were to solve for the antiderivative of this, we can factor out the 1 over 9 in the bottom of this denominator here. And the antiderivative of the square root of u is simply 3 over 2 times u to the power of 3, 2 over 3 times u to the power of 3 over 2. 10 and 1. So really, just plug in everything. 1 over 9, 2 over 3, 10, 3 over 2, minus 2 over 3. Since the 1 to the power of 3 over 2 is just 1, 2 over 3 is left over. So this right is your answer. You don't need to simplify anything unless you're taking an algebra class, not a calculus class. Blah, 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 blah. But as always, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing, liking the video. I'm going to play Grow Garden on Roblox.